there's something bad coming. We are going to be the ones to step up and save the day. And yeah, they eventually teamed up with Pfizer, but Pfizer's not a vaccine company, and at least they weren't. And they didn't develop it. It was BioNTech. So very unlikely characters. Once again, same thing is true of some of the other players. University of Oxford, this guy Adrian Hill I write about in my book, probably the most detested, disliked character in the world of science today, or among them. But he says, hey, we're going to be the ones also to step up, and they threw themselves into it. Novavax is a little company in Maryland. The stock was trading about $3 a share in January 2020. They were running out of money. They only had a few months left before their money would run out. People were sending resumes and quitting the company. And they failed year after year after year. Every kind of vaccine, you name it, they failed at it. And yet they said, hey, we believe in our approach. We're gonna step up. So it's a book about unlikely characters, but also unlikely approaches. So let me just talk briefly about mRNA. mRNA, some I'm sure are experts or know a lot. People on this call, others probably don't know much about it. I'll just briefly give you a little sense of what mRNA is. It's a molecule, stands for short for messenger RNA. We have it inside of us, messenger RNA, to transport the directions from the DNA to the part of the cell where proteins are created that keep us alive. And scientists always wanted to create mRNA molecules in the laboratory, just like we have sugar naturally, but we could also create it synthetically. They wanted to create synthetic molecule, mRNA molecule. Why? So that we can send a message to the body cells to create any kind of protein you want, and therefore create any kind of vaccine or drug you want. That was always the holy grail. But just as soon as people got excited about that idea in the world of science, they usually gave up on it. mRNA gets chopped up really quickly, almost immediately, and eliminated by the body cells. The body's immune system fights it off. So if you want to inject it through as part of a drug or a vaccine, it's very difficult. There are all kinds of reasons why no one wanted to work with mRNA. A little bit ironic, given that some of the vaccine hesitant people say, well, I don't want to take these mRNA vaccines because they're going to change my DNA and they're going to be inside of me. And no. There's a reason why no one ever wanted to work with it, is because it gets eliminated so quickly. So for years, the mainstream science said, don't waste your time with mRNA. And it took some really unlikely scientists who I write about in my book to ignore the skepticism, ignore the conventional wisdom. And I write about the process and about, it's a little bit like a relay race where some scientists make some headway and they are pretty innovative and they come up with some creative solution to create a drug or a vaccine using mRNA, maybe to encase it in a lipid nanoparticle, try to get into the body, but then they meet some roadblock and they give up and they kind of stumble and, as it were, and pass the baton to another group, and they make some headway, and it goes on for years. And these scientists, researchers are really impressive, at least to me. They teach us a lot about resilience and creativity, innovation. I think when it comes to innovation, people think about Silicon Valley, but the labs in our country are remarkable. The biotech world is fascinating. So that's what my book is about, that creativity, that innovation. And I kind of give you the history of mRNA and bring you up to 2020. Same thing with the other approach that led to the Oxford vaccine and the J&J vaccine. That's called the adenovirus vaccine approach. And that goes back to HIV and the chase for an HIV vaccine. And that's also really fascinating and dramatic and fruitless in the end. We haven't developed a vaccine for HIV, but along the way, these characters, they stumbled and fell and met frustration and sometimes gave up, but they developed an approach that did eventually lead to these COVID vaccines, the J&J and the AstraZeneca vaccines. So we have them to thank, these AIDS researchers. So my book is about persistence, it's about resilience, it's about innovation, it's about managing these kind of characters in the lab and getting the most out of them. And it's about 2020 as well, where for the first time ever, we did things simultaneously. We developed, we tested, and we manufactured vaccines at the same time. And that's why it was done so quickly and effectively. So that's an overview of my book. I'd be glad to talk in more detail about any of those efforts, any of those characters, any themes we can talk about vaccine hesitancy. We can talk about the politics. We can talk about innovation, why it was these companies, et cetera. But that's an overview of A Shot to Save the World. And there are some themes that evolve, I think, some lessons from this era. I think it's very telling that some of the countries that did the best, especially those from Asia and elsewhere, did the best in this pandemic are those that maybe care about each other a little bit more. One of the reasons why these vaccines developed from American labs usually, or these approaches did, is we're a country of individualists and there's a lot of creativity. There's also, frankly, investors in this country. And I've talked to the CEOs of all these companies, and they're often foreign born. Stefan Menzel is French. Ugur Sahin, born in Germany. I'm sorry, in Turkey, in traveled to Germany, as did Aslam Turkey, his wife. But they all say without American investors, venture capital, small investors willing to bet on profits way down the road, years down the road. You don't have that in other countries. Without those investors, these vaccines would not have been possible. But the flip side of that individualism is we care about ourselves a lot here in this country. iPhone and self this, self that. There's a lot of I and self as opposed to we. And maybe we could learn from some other countries too. And I think there's some lessons that we can take, because I do think this is an age of, if not pandemics, illnesses. So in some ways, we have to be prepared for more of these kind of events in the future. So I'll stop now. I don't want to take up too much time. We can discuss any of those themes if people would like.
That was a fantastic overview, Greg. Thank you. There's a wealth of detail in the book, I have to tell people. So please, if you're interested in the most important story of the times as it pertains to the pandemic, you got to read. I mean, I love the fact that, you really get into the complex characters in the background, sort of the whole story of not just the individuals, but also how it almost didn't happen in almost every instance. There was so many hurdles and such a sort of zigzag to discovery and success that who would have thunk, especially, because I'd heard some of the stories about the lady at Penn and the early efforts by the Hungarian lady on messenger RNA, and time and again it was scoffed at. But I'm curious. I mean, I guess let me start with the kind of backwards. I guess the most burning question for most people is, what's the end game? How does this all end? Now, early in the pandemic, everybody was talking about herd immunity. People in Britain almost took that approach. In Sweden, they talked about it. But more recently, at least to me, it's been sort of, I've been thinking, well, the RNA-based viruses keep mutating, they keep mutating. So it's not clear, and Jim was hinting at this earlier, that there's an obvious end, right? So just like the flu, every season you're going to get some new mutant. And over time, we'll perhaps build some generalized immunity, but it's not obvious that, if people just go out and try to get themselves infected by Omicron, it's going to help them. Because that doesn't mean you're going to be immune to the next variant.
That's a good point. That's a very good point. So I'm going to give you first reason for concern and then reason for optimism. I don't want to leave negative feel to this whole thing. The reason for concern is, this thing is mutating. We still don't have big chunks of the world that are vaccinated anyway. Africa, elsewhere, 20% or so of our fellow citizens won't get vaccinated. So as a result, this thing is going to keep mutating. Yeah, we had recently Omicron. And not only that, but there are really good indications that this virus will keep potentially, there's a possibility that it'll keep going from animal back to man, animal back to man, a lot of potential hosts in the animal kingdom, and it could keep mutating as a result. So that's reason to think this thing could last and last and last. The reason for optimism is that scientists are developing second and third generation vaccines. And it could be like flu, where every year there's a new type, a new variation, new mutation that we're going to have to prepare for. But I believe we're going to go into our doctor's offices once every year or so, and not only get a new coronavirus vaccine, and they're working on pan-coronavirus vaccines, which is great, but also they'll roll it into a flu vaccine, an all-in-one kind of thing. And I think it'll be relatively effective. And these medicines that are coming up, these drugs, especially the one by Pfizer, are pretty impressive. So if we get to the point where, I do think we're going to get to the point where you're always going to have some virus cropping up somewhere in society, some hotspot, especially among those who aren't vaccinated. They will unfortunately be hospitalized or worse. And the rest of us will have to deal with sickness potentially. But I don't think it'll dominate. I think we will learn to live with this virus and this disease. And yeah, if it means once a year or even once every 9 months going into doctor's offices, it's or CVS or what have you, it's a pain in the butt, but I think it'll also lead us to a semblance of normalcy and much closer than you would have expected. And I think even come the summer, next few months, I think things will start getting much better, and you'll see. It'll be reassuring for everybody.
Right. Well, I think Henry and Jim had both touched on this point about which you mentioned. We were talking about Moderna's stock price and thinking, well, what's going to finally get it out of the funk that it's in right now? And presumably one of those combo flu / COVID shots could be a huge catalyst. That'd be a nice, steady, recurring revenue stream for the company. It's not a one-and-done type of thing. But also, have you heard any chatter about, in theory, this is such a powerful new technology and platform that you could potentially reinvent all the vaccines, right? Like, why couldn't they just redo, if they can sequence polio and chickenpox, why couldn't they redo everything with 95% efficacy, which, by the way, the traditional vaccines are not that efficacious?
Yeah. I'll adjust some of those points. Well, Moderna is not the only one working on these all-in-ones, pan-coronavirus, flu, etc. Everybody. Novavax has a really interesting flu vaccine. Moderna has been kind of slow when it comes to flu, but they have other things they're working on. RSV is a virus that people have been trying to combat for years. It kills children, it kills elderly. I'm more optimistic about that. CMV is another virus. They've got an approach that they're working on, and I'm optimistic about that. I'm not one of these people that says, wow, mRNA worked on COVID-19, so why can't it change everything and save everybody and every disease and because we haven't seen any indication of its effectiveness before 2020. And they've tried with other things. It's not to say that they won't. You guys know as well as anyone, now that they've made all these profits, more money is going to come into this area, mRNA, resources, talent. And one thing I've learned is not to count these people out. And they're hard at work. All these labs, BioNTech has taken this money and they're back to trying to figure out cancer. And Moderna is going all out. And they just kind of see this as a first chapter. So that's reassuring too. There are reasons to think that you need some new advances and revolutions for mRNA to work with other kinds of cancers where you have to target parts of the body, but they could get there.
Yeah. Well, it's exciting from an investor's standpoint. Let Henry jump in.
The question, do you think the mRNA would be the new technology that will replace the old traditional vaccines eventually?
Like measles, mumps, rubella kind of thing? No, yeah. Because those are pretty effective. I do think there'll be other, sadly, viruses that emerge. And then mRNA is quick and fast, and we've seen that, and we are going to turn that, and the government has learned that. So yeah, mRNA will be the go-to for future viruses. I do think that, yeah.
Have you heard anything about, so with cancer, we have very limited instances like HPV, right? So for cervical cancer, for HPV quas stuff, you can actually, there is a vaccine. Is that
and it's very effective? Yep. And not enough people take that. Yeah.
But is that a direction of research for Ugur Sain and folks like him who were originally kind of cancer specialists? That, I mean, is that the way to go? You try to build a vaccine against all types of cancer, or?
I'm trying to remember what I wrote about in terms of what they're focusing on. It's not HPV. I mean, you already have a quite effective one there. They've been, I think it's more personalized, cousin of sort of the CAR T approach. And I thought it was more blood cancers. I'm not sure, but they, yeah, everything I know about them is that they're trying to innovate and keep up, and they're not sitting on back on their laurels and counting their money, and that's something that's very encouraging.
Yeah, yeah. Well, he definitely seems a very driven personality who's not focused on. He's not exactly throwing you out parties. I mean, he's back.
Yeah, that's exactly right. I mean, those who've read the book know that Ugur Sain lives in an apartment still. He doesn't have a car. Likes to work. He is not taking these billions, and he's a billionaire, but he hasn't cashed out. He doesn't really care. He wants more control than anything else. So he hasn't sold shares. And that's reassuring just as a citizen, as I guess as a shareholder too. I'm not a shareholder, but I'm saying if one was to be a shareholder, yeah, he just wants the next event. And it's kind of fascinating. This is not what he set out to do it, a breakthrough in infectious diseases. His whole life's goal has been cancer. So he doesn't believe he's close to fulfilling his life goal, even though he's saved, thousands, hundreds of thousands of lives, maybe more.
Yeah, absolutely. Want to open it up to others, get some more audience participation if we can, guys.
I have a question, Millen.
Yeah, Jim, please.
Greg, hi. I'm very close to, let's say, nature. I'm all my life I've been a close observer of everything from butterflies to hawks, falcons, birds, pheasants, grouse, woodcocks, you name it. Over the last year, we had a massive die-off. I live in Connecticut, southern Connecticut. We had a massive die-off of birds. And it hasn't really been explained. I picked up, in particular, catbirds got hit hard by whatever it was. Even hawks, like I had a Cooper's hawk in my yard. I had to pick up and take to a rescue center where it died. Right. But my fear is that I believe, and of course I can't prove it, but I think this virus is, well, we've seen the numbers about deer, I mean, this area is inundated with deer, and particularly my yard is because I feed them. Don't tell anybody, but I think this virus is now well ensconced in the wildlife population, which means that we could have like a boomerang effect, went from humans to the wildlife, and it's going to possibly bounce back as another different version, right? Which is none of the wildlife have been vaccinated. So, yeah, any comments on that and the possibility about another bizarre mutation?
That is what I referred to earlier. I agree with that. There's a real good reason for concern about that. You find the virus in many different animals, and it's not clear why, but there's interaction, I guess, and we're encroaching on the animal kingdom and having maybe more interaction with animals, and it's a little scary. But the flip side is that Omicron, I remember talking to researchers at Moderna elsewhere the weekend where Omicron became a concern, and they were very nervous. This thing had 50 mutations, and when you develop a potential of a virus with that could be the most challenging one out there, the Omicron is kind of close to what you're going to find. And yet these vaccines are really effective against Omicron. It's crazy. I mean, they've developed new vaccines that use the sequence of Omicron, but they haven't needed to use them. Remember, we're still using the original vaccine. It's kind of startling to me. It's remarkable how effective these vaccines are against Omicron, even though they haven't really rejiggered them. So yeah, this virus will keep mutating, I think, and we have to be on our wares, and we're gonna have to deal with it for years. But we need to also be appreciative of how remarkable these vaccines are, and they can change the sequence of these vaccines and adjust them and make them even more effective.
Yeah.
Thank you.
Great point, Jim. I only recently heard about the deer, actually. But, you know, I can certainly attest to the sort of accidental efficacy against Omicron, because we've had quite a few conferences here in Miami lately with thousands of hedge funders stuffed into the Fontainebleau and neighboring hotels. Obviously, no masks, this being Florida. So
yeah,
I came out of all those conferences without a cold or a cough is probably a good sign.
Yeah, that's correct. That's correct. We have the vaccines and the researchers in my book to thank for that.
Absolutely. So let me ask you on this note, you know, because the dominant narrative I heard with Omicron is that, you know, people became immediately dismissive of, well, it's so mild and it's nothing. I had it. It was just like a cold and blah, blah, blah. And it's, you know, you just learn to live with it and whatever, right? That's sort of become the dominant narrative. Now, as a mathematician, I always sort of think more axiomatically, like, is there a theorem proof that says, well, does it have to be the case that the virus is going to become more innocuous? I'm actually not sure, but is there anything in the science that says that over time, if it mutates, it's got to become more transmissible and less virulent? Or, I mean, it's a trade-off, right? The virus, it's kind of in the interest of the virus to also, you know, not kill the host to, you know, if it wants to spread. But what have you heard?
Yeah, that's true. I've heard different theories. Some say, hey, we got through Omicron where the coast is clear and the future mutations won't be that dangerous. Some people say this thing has surprised us left and right over and over again. Don't get too cocky. It's too early to say that. It's not necessarily the case. So I've heard different theories from scientists about that. And I do see a question from Michael. Any conjecture to which researchers are most likely to be recognized by the Swedish Nobel Prize? Yeah, so the Nobel Prize, people talk about Carrico and Weissman. I write about them in my book. Katie Carrico and Drew Weissman from Penn. They developed the way to change the chemical basis of mRNA, the molecule in the lab, such that it avoids triggering the immune system. I write about it in my book. Very dramatic what they did, very impressive what they did. They could very well win it. It's fascinating because I can make an argument for them and against them. So are they more likely than others? Yeah. Did we necessarily need them? I don't know. The AstraZeneca one doesn't use their chemical modification. It's pretty effective. It's not as effective as the other ones. Others would argue CureVac's a company in Germany that doesn't use the Carrico-Weissman modifications, and they haven't been able to produce a vaccine that's effective, but some people think they'll be able to. Some people are just not sure yet whether their modifications are necessary. Not only that, I don't think people realize that their modifications actually are not used in any of the vaccines. The principle they developed is the fact that you modify the chemical basis of the mRNA to get around the immune system. But there was a gentleman, a researcher I write about in my book at Moderna, who came up with the actual modification that's used by all the vaccine companies in these COVID-19 vaccines. So it's a complex question. My understanding is it takes a little while. They have to do their research. The people on the committee. I'm not sure it's going to be handed out so quickly, like next year people expect, but it could.
Well, I like that in the book you called it the bug that became a feature. When the gentleman at Moderna recognized that, you know, what was a bug was potentially a feature if you pivoted the company towards a vaccine company instead of therapeutics.
Right, you're referring to the fact that originally they wanted to be a drug company, a therapeutic company. It was called Moderna Therapeutics, and it didn't work. And they weren't going to not give up, but they were frustrated. And they had to pivot it to vaccines, right? And there's some lesson there in science and innovation, creativity, adjusting on the fly, resilience. I find these researchers just fascinating, just how they go into their lab and they try to make incremental progress on a daily basis. And some days they're able to, some days they're not, and they keep at it. There's a lesson for me anyway, maybe for all of us there.
Yeah, but it makes sense. I mean, I'm glad Michael asked that question, because obviously the impact they've had, regardless of who gets the credit for the discovery and so on. But, you know, I mean, we're all living testaments to the fact that we're still here, and clearly it's had an impact. I mean, it's not, you know, and it's much more tangible than, for instance, the Peace Prize tends to be a bit more, you know, it's less subject to quantitative criteria, perhaps. I mean, my high school got nominated for the Nobel Peace Prize. I know that's very unusual.
Wow.
But it's an unusual kind of school movement. So in any case, but that's fascinating. I mean, so you think it might be Carico and Weissman. Do you mind kind of explaining to people how the Novavax folks are a little bit different, because they're kind of the, you know, the underdog in this, right? I mean, till recently, nobody took them seriously, heard about them. The stock was all over the map. And, you know, I guess they've now been approved in some countries, but not in the US.
Yeah. So the mRNA vaccines, that's the Pfizer, BioNTech one, and the Moderna one, as well as the adenovirus vaccines, that's the J&J one and the AstraZeneca Oxford one, they send a message, a genetic message. They send a message to the body to create a protein. What's the protein? It's the spike protein. Why do we want that? Because it teaches the body. It's an education. That's what a vaccine is. It educates the body. First, you create the spike protein. The body learns to fight it off, and then it's ready, prepared for if it's ever encountered for real. The Novavax approach is a little bit more traditional. It's not like an old style approach. Some people go overboard and they say, oh, it's proved and old and mainstream. That's more the vaccine approach that we all are aware of, like the MMR one, where it's a piece of the actual virus, or it's attenuated, a weakened piece of the virus, or killed by. That's not what Novavax is. Novavax, it's called a protein subunit approach, where they create in the laboratory a protein, obviously in this case, it's the spike protein of a virus. And then they figure out using an accompaniment, a way to get it into the body. And so instead of telling the body to create the spike protein, the Novavax one inserts the spike protein into the body, but then the same kind of thing where it educates the body's immune system. And it's a really good approach. It's been very effective in trials, maybe even more so than mRNA ones. Does have to be kept in cold temperatures. I'm a fan of it. The problem is they're a small, dinky company, and they've had very little history in terms of running trials, but also manufacturing. And they've had issues just ensuring manufacturing. Every vaccine has to be the same, obviously. And they never found a partner. They tried a little bit here and there, but Pfizer was stepped up and worked with BioNTech. Moderna couldn't find a partner either, but they had the government to work with them. That helped. Novavax had no one. I mean, they got a lot of money from the government, but they didn't really have a partner in turn, and they got kicked out of the manufacturing facility that they originally had. So they've had a lot of challenges, but I do think eventually they're going to prove to be a company that develops. I mean, this vaccine is going to be helpful elsewhere. We don't really need it in the United States, but elsewhere in the world, I think it'll be helpful.
So like Moderna, they did not have any revenues or proven products prior to this. In fact,
none of these guys did. BioNTech didn't. University of Oxford didn't. Yes, J&J obviously did, but there were no vaccine companies. Pfizer was a vaccine. That's part of the crazy theme of this thing.
Well, I may be a little biased as an alum of Oxford, but I think that the medical school, I mean, you know, Oxford's actually had a long history of penicillin and everything, you know, going way back. I mean, I was
referring to Adrian Hill and his lab.
Specific this group, right? Yeah. And the other lady, I forget her name.
Yeah, liking to.
But and you talk about the controversy in the book, which was very colorful. I thought that was interesting because I heard some of that from the faculty when I got to meet with some of the people. But actually, let me ask you this. I've actually noticed, and maybe again, it could be just my bias, sort of maybe reading too much of the Oxford research, but between Oxford and Imperial, it seems like they came out a lot of the groundbreaking studies on COVID, particularly, things like cocktails. Do you use this with that or combine this? And all those types of things were done by Oxford and to some extent Imperial. We didn't see the same level of innovation coming out of, Hopkins or Harvard, which kind of surprised me.
Yeah. Listen, historically, this hasn't been a focus. Again, vaccines are not a popular area of study, for a lot of people. For those reasons, not much upside, not so sexy. It's hard to believe because, the Pfizer vaccine is going to be the biggest seller in the world, selling drug or vaccine. But again, until 2020, vaccines were not a popular area of focus for people all around the world.
Well, you mentioned some of the missteps, right? That in the past when they created one for Ebola or something, and then it sort of disappeared. So
Zika, earlier coronaviruses. Yeah, a lot of people chased them, and then they went away, and they wasted their time, wasted a lot of money. Merck spent a lot of money, millions of dollars wasted. I forgot which one of the earlier pathogens. And by 2020, a lot of these guys had learned their lesson, and they said, we're not chasing this thing. What if it doesn't spread? What if it doesn't become a pandemic? What if we can't succeed? What if we can't build a vaccine that works? And we have to be thankful for these unlikely researchers. We really are not grateful enough, and meaning society in general. Even the people that take the vaccine and roll up their sleeves, a lot of people are still, I hear about these side effects, or I had to do a booster. Hey, they told me that no one would get sick, and now they're telling me I need to get a book. I don't remember whoever promised that. No one gets sick, and these are remarkably effective vaccines. I don't know. It reflects something about us today, civilization. Everybody's got some complaint. Everybody heard from some uncle's friend on YouTube about some side effect, and there's no evidence of that data. But yeah, I don't know. It's sad to me in some ways.
Yeah, well, I mean, I couldn't agree with you more that people, because of social media and all the misinformation. I mean, just starting with, if you've got public figures calling it a hoax, and I'm in a state where they have no mandates at all. You're actually not allowed to check anything. Right now I'm sitting in Florida, and in this state, even if the conference wants to check, they're not allowed to check. So
wow,
it's pretty ridiculous.
Yeah, listen, mandates is a question if that's what we should be pursuing. I'm not a fan of mandates, but the flip side is we tried other ways of persuading people. A lot of people will say, wow, why do they have to do a mandate? They should just educate us and try. We tried all that. We tried. You have to remember that they spent a year trying. So again, I don't think mandates are good for anyone, but we have to get people vaccinated. All right, Michael asks, where would we be if Pfizer had not agreed 2 years ago to help BioNTech in testing and manufacturing vaccine? It's a great question. And it could have gone either way. So BioNTech, those who read in the book, they reached out to Pfizer, and early on, Pfizer said, nah, let's not waste our time on this thing. We're working on a flu vaccine with you, BioNTech. Don't waste your time on COVID. And luckily, Ugur Sahin spoke to another senior executive, senior scientist at Pfizer, and Kathleen Jansen, and they decided to work together. But where would we be with just Moderna's vaccine? I guess we'd probably have to go to use Novavax and the AstraZeneca one, which are good, but not great, and Johnson & Johnson, which are good, but not as effective as the BioNTech one.
So I've heard some rumors that some company in South Africa maybe reverse engineered the Moderna vaccine from the Stanford, genetic makeup that they published. Have you heard about this?
I have not. No, I have not. And then what? They'll give it out for free or something?
Something like that. It's very recent that they claim that they've got sort of the generic version of Moderna. And
I mean, listen, they as you know from the book, they spent years and years and years perfecting this approach. So it's not easy to do. mRNA is quite the challenge, but people could figure out, improve on it. That'd be great.
Well, I've also heard something lately about J&J giving up. Is that something you know?
I think they put it on hold just briefly. Yeah, we reported that, or somebody reported. I think the Times they reported that. Yeah, that I forgot why. Just for maybe a few weeks, they put the production on hold. We haven't really needed. I mean, if you remember, at one point that was the hot vaccine, and all the ball players were taking it. These poor baby baseball players and others who can't get they're too busy and they're too nervous to get 2 shots. They have to have 1 shot. They're too scared to get 2 shots. But anyway, a lot of stars, Hollywood, others, they love the J&J one. I don't know what it is about it, but we haven't really needed it so much in this country. So they had a big market share early on. There was a scare or two I wrote about it, but it's still an effective vaccine. If that was the only one we had, we'd all be rolling up our sleeves and taking our guides for that.
Well, it works, and I guess the initial, I think they got a bit of a bad rep initially because the efficacy was not indicated to be as high, but then later on there's some studies that suggested if you did 2 doses of J&J, it's actually just as good, but you got to have the second dose.
I still don't think it's as effective. And there are some examples of women, younger women, childbearing women who've had some issues. So it's not an ideal one for them. But frankly, there are a couple of issues for young males when it comes to mRNA ones. So for a young man to try the J&J one, I don't think that's a bad idea. My 2 sons both did the mRNA ones. It's still such a small percentage of side effects. Yeah.
Do you think the mix and match approach takes off? And then since we're likely to have a 4th and a 5th and God knows how many boosters down the road, I mean, is it, at least what I've heard from from doctors in the family and medical community is, there's much evidence for trying to get different types of resistance in your body, take a different vaccine.
Yeah, I too have heard that from scientists, and I've thought about it. When I did my booster, I was thinking about doing a J&J. You want to introduce potentially to the immune system different approaches, different ways to teach it, and different education kind of thing. But I just went with the Pfizer one. But eventually we could do mixing and matching. Yeah, there's an argument for that. We have to probably see some more data to prove that.
Yeah, well, hopefully there'll be lots more studies coming out soon.
Yeah.
I'm sure there'll be enough to pack a sequel if you ever want to.
We'll see. We will see, and hopefully there's not a new pathogen illness that
you
evolves, but we'll see. But yeah, I'd love to stay in touch. If people have any questions, feel free to email. I'm easy to find on LinkedIn or email or Twitter, what have you. And I hope people enjoy the book. And I welcome constructive criticism as well. So feel free to reach out to me about this book or about my previous books as well.
Absolutely. And okay, well, thank you, Greg. This has been fantastic. And one last question. Have you got any call from Hollywood yet? Or does anybody make a movie about this?
My book has been optioned. We'll see what happens. You never know if they'll make it, but supposedly there's a screenwriter working on it right now. HBO optioned it. So it's my first book that Hollywood has really shown. I've had a little interest, but not too much in my past books. So yeah, maybe you'll see this in, I would say the theater, probably, I guess on your screen. Who knows, a few years from now, but you never know with these things if they actually end up doing it. But hopefully, fingers are crossed.
Yeah, absolutely. Well, I mean, I'm surprised that they didn't call you about the Jim Simons book. I would have a movie about it.
Me too. Yeah, maybe someday. I kind of hope if this one does okay, then they might reach out to me about Simons and his crew. So here's hoping.
Yeah. Well, somebody made a book about the the whatever Biggest Short or something, I forget, you know, which had
Sure. Yeah, right.
our ex-colleague from Deutsche Bank. You know, I mean, it's nice if you can have Ryan Gosling playing you in real.
Greg Lippman. Yeah.
In any case, well, fantastic, wonderful. You know, big round of applause for Greg Zuckerman. Thank you so much.
Thank you for having me. Thank you for being in touch, and thank you for the interest in the book and me. And yeah, feel free to reach out to me. I love to interact with people individually.
Yeah, and also next time when I see you, I want your signature on the book.
You know, I've been trying to go into the city more frequently recently. I miss it really very much, and I meet people for coffee and such. So I'd be glad to reach out to me. Be glad to meet you somewhere and sign a book. Just send me an email. I'm easy to find, gregory.zuckerman@wsj.com, and it's an excuse to meet people again and to go into the city. So I'm looking for those excuses. So please reach out.
Thank you. It's Henry Ying.
Yeah. Okay, Henry. Yeah, send me an email.
Okay.
All right, guys, such an honor to have you again, Greg, and we'll look out for your next book. Hopefully see you in April for dinner. I'm going to bring my book in April to get it signed. So thanks again.
Sounds great. Stay well, everybody. Stay in touch.
Thank you.
Okay. Thanks, everybody, for joining. Cheers. Good night.
Good night.
Good night. Thank you very much.
Yeah.